All right, these are our problems that go along with working power. So I'm going to go through a few of them with you, and then I'm going to show you the answers here so that you can look over your sheet and check your answers as well. So when it says write the formula for finding work, we write work is equal to force times distance, and we plug into our triangle if you would like that. The SI unit for force is a Newton, for work is a joule, and for distance is the meter. So look at this one. Suppose you want to calculate how much work it takes to lift a 160 Newton barbell. Besides the mass of the barbell, what other information do you need to know? And that would be B, how high the barbell is being lifted, because I need to know this is my force, right? And so this would be how high would be my distance. So I would also have to know my distance there. Okay? Now, let's look at number 4 here. I'll work out number 4. I'll put a, you can obviously see the answer there. But all I have to do is I look at, well, I don't have to work it out. I can put it right here. Work is equal to force times distance. That's my formula. I plug in the values, 90 times 5, and I get 450. And you notice I've got a J there for joules. So the same thing here. Distance, if I'm looking for distance, it would be the work divided by the force. That's my formula. Remember, I'm getting those formulas from that little triangle, right? Work, force, distance, like so. So if I'm looking for distance, okay, distance is equal to, that's what I'm left, work divided by force. So that's how I got that formula right there. And then I plugged in the 72. Now the thing to get 12, you have to plug in 72 in the calculator first, 72 divided by 6. And then I'm looking for distance, which is meters, okay? Now, we talked about this in class as well. If I'm plugging in my 72 joules of work, remember a joule is the same thing as a Newton meter, so I could write it like that. And then my force is going to be 6 newtons. So when I look at my distance that's left over here, I'm going to cancel out my newtons and I would be left with the unit of meter. So that's how I get 12 meters mathematically. But obviously, if you know, well, distance is measured in meters, then you would know to put meters there. Okay, and then number 6, the same thing. This time I'm looking for force itself, so I'm going to use my triangle, same triangle. I'm going to cover up force this time. So force is equal to work divided by distance. So my work in this case is my 120 joules, right? So that's a 120 Newton meters. And then my distance that it travels in this case is 24 meters. So my meters cancel out, and of course I'm looking for force, so I'm going to wind up with the unit of a Newton. That's how that works. And so 120 divided by 24, if I plug that in the calculator or do the longhand division, either way, I know that that happens 5 times. So 5 times 24 should give me back my 120. So I have 5 newtons of force being applied there. Okay?
Teachers, I need these two to come to the front office, please. Albert Franklin.
I'm going to show you the rest of
Sailor, Trey McCoy,
these.
Jamari Colson.
Well, I'll wait till after the answers. It's just like being in class.
Stephen Moore, Kason Adeline, Jordan Brees, Dana Roberts, Morningstar Southern, Logan Sumner, Dustin Taylor, Willie Polk, and Markevius Carver. If you guys could come to the front office at this time, thank you.
All right, so here we go. We're going to look at these. These are just, I'm just showing you the answers here. So number 7, you should have got this number, 813.8 joules. Number 8, 6.6 meters. Number 9, 5 newtons. Number 10, that is not OJ, that is 0 joules. And the reason this is kind of a trick question, if I look at the force, this girl is applying 45 newtons of force to a bench. How much work is done on the bench? Well, remember, work is force times distance, right? So my force, even if you wanted to add those together, but you're looking at the work on the bench. But anyway, my force times distance. How far did that bench move? It did not. So therefore, whatever number I get over here times 0 is going to give me 0 joules. All right, so boy lifting for number 11, that is 60 joules. For number 12 is 700 joules. For number 13 is 2.7 meters. Number 14 is 200 joules. Number 15 is 4,000 joules. Number 16 is 90,000 joules. Number 17 is 45 joules. Number 18 is 429 joules. Number 19 is 300 joules. Number 20 is 15 newtons. Number 21 is 2 meters. Okay, if you need any of those worked out, you can kind of see my shorthand without all the steps. But if you want to work some of those out, tutoring is every Thursday, 3:15 to 4:15, or you can see me during homeroom or after class or in class, or just come to me at the beginning of class or something. We'll work them out together. All right, let's look at the back side. The back side here, number 23, the baseball player, or sorry, 22 at the top. You end up with 12.34 newtons. And then for number 23, this is really, because this is 1 kilometer, I didn't quite catch that. I tried to change all of those. 1 kilometer is the same thing as 1,000 meters. And since we're talking about a Newton meter, it wouldn't be 50 joules, which you would probably want to say. It would actually be 50,000 joules, because it'd be 50 times 1,000 for 1,000 meters, because it's a Newton meter makes a joule. So it's 50,000 joules in that case. If you didn't catch that, that was fine. I meant to change all of those so you didn't have to convert. I just missed that one. Number 24 is power. Number 25, a watt is the unit for power, a joule for work, and seconds for time. The formula for power is equal to work divided by time can be written as power, or work is equal to power times time. So work, power, time. So again, you can fill in your triangle, and it works like that. Number 27, your power is 20 watts. We haven't done one of these. I worked these out in class. I'm going to work these 3 out with you. And then you can obviously see my work here, my shorthand work, but we'll work them out. So number 27, the way that I'm going to work this one out is I'm looking for power, which is work divided by time. So that is my formula, and I'm using my triangle here. Power is work divided by time. So what I have to do here is I have to plug in 500 joules for my work divided by my 25 seconds. So remember, a watt, which is my unit for power, is a joule per second. So I'm going to go ahead and change that to watts, but it's a joule per second. But then 500 divided by 25 is going to give me 20, and that's watts. Now, if you wrote it as 20 joules per second, it's not necessarily incorrect, but you just need to know 1 joule per second is equal to 1 watt. So when they give you the choices, this is going to be the choices they give you, because this is the SI unit for power. And 1 watt is equal to 1 joule per second. So that's where that comes from, and that's in your notes on that conversion. But it's a 1-for-1 conversion, so that's pretty easy. All right, over here I'm looking for time. So in order to get my time, using my triangle, if you want to use a triangle, I get work divided by power. So work divided by power. So I've got my time is what I'm looking for, and my work is 5,000 joules, and that is shown here. Okay, divided by my power, which is 25 watts of power. Okay, and then I'm going to end up with 200 seconds. Now, you think, okay, well, I've got seconds and that's time. That is correct. But why isn't it a joule per watt? Well, because remember, we have a watt is equal to a joule per second, right? So my joules are going to cancel out. That's why. So I'm only left with my second. All right, so number 29, dismissal there. We're looking for watts. And so, or sorry, not watts. I'm looking for work here, not watts. And if I cover up that, I know that it's power times time. So this one's kind of easy. So I know my power is 170 watts, right? Times 20 seconds. So I'm looking for my work. So work is equal to 3,400 joules. Okay, so that is that one there. Again, we're looking for work. When I'm at power, I've got watts, which is a joule per second, right? And my time is seconds. And when I multiply, this is in the denominator here. I was trying to watch the screen instead of what I'm doing. My seconds would cancel out. So really, again, if you're getting caught up with the units, it's like over 1 second times 20 seconds over 1. So that's why my seconds cancel out there. And then I multiply straight across and get my 3,400 divided by 1. Hey, how are you? Okay, so here we go. We look at number 30. Here's our answers here. For 30, you got 10 watts. 31 is 9 seconds. 32 is 300 joules. Number 33 is 20 watts. Number 34 is 24 seconds. Number 35 is 1,602.4 or and 4/10, and that's joules. Number 36, sometimes we've had some issues working this one out. So I'll go ahead and work this one out for you so you can go back and look at it if you need to. You can see my shorthand work. All right, so here we go. We're looking at number 36. And the other ones are kind of like this as well.
Teachers, if we need a tutoring bus, call 4204. If we need a tutoring bus, call 4204, please.
Get this on there. Okay, so anyway, here we go. We've got some given things. So what I always do is I write down what I've been given, or as I read the problem, you know, I can identify what those things are. So I like to write them down. So my force is given as 600 newtons. A person weighing 600 newtons gets on an elevator. The elevator lifts the person 6 meters. So 6
We
meters
will have a tutoring bus, teachers.
is our distance there. And then I'm given 10 seconds, which is a time unit, 10 seconds. So I want to know how much power is happening here. So that's what I'm looking for. So if I'm looking for power, I have to get the formula. Okay, so I went to my notes and I got the formula. I know power is calculated as work divided by time, but they didn't give me any work. So what I have to do is I get 2 problems for 1, basically, is I have to figure out, well, what is work? So I think, okay, well, work is the force times the distance. So I do have the force and I do have the distance. So multiplying that together, I can get 3,600. Okay, and that's a Newton meter, so that's newtons times meter, so it's going to give me 3,600 joules of work. Okay, so now for my power, I have the time and I have the work, even though I had to figure that out, and now I just plug it in. So 3,600 joules of work divided by 10 seconds, and a joule per second is going to be a watt, remember, because I'm looking for power, so a joule per second is going to be a watt. So 3,600 divided by 10 is going to be 360 watts of power. So that's how I get the 360 watts right there. All right, and here's the answers for the other ones. Number 37, you should have gotten 8 seconds. Number 38, 1,224 joules. 39, very similar to number 36, the way we did it. 200 watts is your answer here. You had to find your work, which was 3,200 joules, and then you plugged it in and divided by your time and got your 200 watts. And then number 40 is 5 watts. Okay, and again, you had to do that one kind of the same way. You had to find your work first. All right, if you have any questions about any of those, again, you can come see me. We can work them out. Homeroom, tutoring, Thursdays, 3:15 to 4:15 in my room. Just let me know. Homerooms, before class, after class, during class, at an opportune time will be fine, and I'll work through any of those with you. All right, I'm going to end this session. If you need something else, let me know in class.